Hello, I am Lover Tudor and welcome to this video on overriding property getters and setters in Kotlin. In this video, we will have a quick recap on what properties are in Kotlin and see an example of a simple property declaration. Then we will take a look and create our own custom property getters and setters and see how we can simplify these by overriding a properties getter and setter. After which, we will take a quick peek at property delegation using the by keyword with a delegate. And finally, we will look at some tips and best practices. So let's get started. Properties are named variables that are declared inside the class but outside of any method, which is a way to encapsulate data in Kotlin. They also make it possible for you to create a single point of access for reading and writing a variable's value. To declare a property, you use the val or var keyword followed by the property name and type. For example, for this property, we have val signifying that it's an immutable property and cannot be changed once it is initialized. The number of rooms, which is the property name, and an integer type. The same goes for the number of stories. Val, number of stories, of type integer. So the number of rooms and number of stories are the properties of the class building. This means a building will have a particular integer number of rooms and stories, and so we can create a one-storied building with 2 rooms. Properties can be initialized inside the primary constructor of the class, like you see here, or within the body of a class, but outside of any method. Kotlin provides defaults, getters, and setters for properties. This means that you do not need to explicitly define a getter and setter for a property unless you need to customize the behavior of that property. Let's go into the IDE. Here, we have the building class with properties number of rooms and number of stories. And going to our main function, I will create a one-story building object called my home. So for the number of rooms, I'm going to pass in 2, and for the number of stories, I'll pass in 1. And now using the println function to print out the number of rooms. Hello, my home has my home dot number of rooms and is 1 storage, I think. Yeah. Okay, so now we can run this and we would see that we've been able to access the number of rooms, the number of storage properties from my home without having to write any code, any extra code, because by default Kotlin provides getters and setters for properties of a class. And now let's do something interesting. So here I can say my home dot number of stories is equals to 6. Well, I cannot set this here because remember it was a val, so I have to change it to var so that it would be a mutable property. Yes, so now they are both mutable properties and I can change them. So I can change number of stories to 6 and number of rooms to, let's say, 2 each floor, so 12. I'm running this. Yeah, we can say, hello, my home has 12 rooms. Oh, I did not append rooms here. And let's run this again. Okay, hello, my home has 12 rooms and is 6-storied. Now let's show you something interesting. So I can change the number of stories to -6, and it's going to run fine. Hello, my home has 12 rooms and is -6-storied, which doesn't really make sense. So now this is where having custom setters come into place. So now I can specify that I do not want negative values for my number of rooms and number of stories, because that doesn't suit the use case. Now we're going to create a custom setter function which will help in filtering out the negative values. So set number of rooms, it will take in an integer value. So we would have an if statement. If value is less than 0, then we would print out number must be non-negative. Else we will set the value to the number of rooms. Great, so we will just duplicate this for the number of stories also, and we would call this number of stories. And we're good to go. So now going back to the main class, we are going to run the main function. And yes, it crashes as expected. Taking a look at the logs, it says Kotlin platform declaration clash. The following declarations have the same JVM signature, set number of rooms. So what this means is that there is a duplicate method called set number of rooms with the same method signature. And this is because, as I said earlier, by default, Kotlin creates getter and setter methods. And so Kotlin already has a method called, and so Kotlin has already created a method called set number of rooms and set number of stories under the hood for this class building. To work around this, we're going to rename the methods to set number of rooms. So I'll refactor this and make the number an abbreviation of number. And I'll do same for the stories. Great. Now moving back to the main function, I'm going to do my home dot set number of stories to -6. Running this now, yeah, we see that it prints out number must be non-negative when we tried to set the number of stories to a negative value of 6, and then it's when we print out the number of rooms and number of stories, we get the previous values that were added, that is 12 rooms and 6 stories. So this is how you can create custom property getters and setters for your classes. As you can see in line 5 and 6, the user can still have access to the properties, and set the number of stories and number of rooms to whatever value, and that way we would not have control over the values being negative or positive. So what we're going to do now is to encapsulate these properties by making them private and only accessible through getter or setter methods. So we'll go to the number of rooms and make them private variables. Going back to main, we're going to see that we're having a bunch of errors. It's saying cannot access number of rooms because it's private. This means that we can only set the number of stories through the contract, set number of stories and set number of rooms. This way we have full control over the values that will be assigned to number of stories and number of rooms. So now I'm going to call the method set number of rooms. And set number of stories. And here in our println function, we can see that we don't have access to the number of rooms. So we would have to create a public get function since the number of rooms is now private. We're going to create the function get number of rooms. Again, we are using the abbreviated numbers so that we do not have conflicts with the default getter generated by Kotlin. So the get number of rooms does not receive any value, it just returns the number of rooms. And we can do the same for get number of stories. Alright, so here in our println function, we're going to get number of rooms and get number of stories. We would run these to be sure everything is working great. Excellent, so everything is working fine now, and we have made use of encapsulation to ensure that our properties are protected from being assigned negative values. Kotlin allows you to override the default getters and setters for properties using the get and set keywords respectively. To override the default getter for a property, you use the get keyword just after your property declaration and provide a custom implementation within the getter block. Like the example we see here, within the get block for the number of rooms property, we return the number of stories times 2. This means whenever you would want to access the number of rooms for a particular building object, it would return the number of stories times 2. So if the number of stories is 10, then it would return 20 as the number of rooms. And if you would want to set the value for the number of rooms, the value has to be greater than 0. Let's get into the IDE and implement this in our building class. To override the implementation of the default property getters, firstly, I will move the property declaration from the primary constructor to the body of the class, like so, and give it an initial value of 0. And also remove the private visibility modifiers, since we would expect the number of rooms and number of stories to be accessed directly from the main function. Just beneath the number of rooms declaration, we're going to call the get function and return the field. So the field here stands for the number of rooms. So whenever the number of rooms is called, it will return the field value. And for the set function, we already put some logic for setting the number of rooms, so I will just copy that and paste it in here, and I'll change the number of rooms to a field which represents the number of rooms, which is the backing property of this setter. And we will do the same for the number of stories, so we'll just copy and paste Perfect. And now we can safely delete the custom getters and setters we created earlier. Going to the main function, we should expect a bunch of errors because these methods don't exist anymore. So we are going to directly access the properties here. Number of stories is equals to 6 and number of rooms is equals to 12. And we're also going to try to set the number of stories to a negative number to see what happens now. And now because we've removed the properties from the primary constructor, so we're going to remove this also and also directly access the properties from here. Number of rooms, number of stories. And running this, yes, it works as expected, just the same way our custom getters and setters did. The number must be non-negative is called when we try to assign a negative value to the number of stories, and then it prints out the previous values that were assigned. So this is how you can override the default property getters and setters in Kotlin. Property delegation allows you to delegate the implementation of your getter and setter methods for properties to a separate object known as the delegate. The syntax usually is a var or a val, then the property name and the keyword by, followed by the expression, which here we are calling it the building validator. The expression after by is called a delegate. So here the building validator is a delegate. This is because the get and set methods that corresponds to the property number of stories or number of rooms will be delegated to the get value and set value methods of the building validator. Property delegates don't have to implement an interface, but they have to provide a get value function and set value function. For example, this building validator class has a function called get value and set value. So when we try to get the number of rooms, which delegates to an instance of the building validator, we would call the get value, and we can see that the get value has a first parameter of type building because this validator is built specifically for the building class. It could also be a type any if you would want to create a generic delegate. The second parameter is a description of the property itself, which could be the property name. And as you would see in the set value function, it has a third parameter called value. Now this is the value you would want to set for the property. Let's get into our IDE and delegate the implementation of getter and setter methods for our properties to a separate building validator object. Firstly, I will create a class called building validator. With a property called number. I'll give it an initial value of 0. Then we will create the get and set value functions, which we will delegate to the getters and setters of our building class properties, number of rooms and number of stories. So operator fun get value, which would have a parameter called building of type building, and the property this would return an int. I will just say return number. We will do the same for the set value function. But this time around it would have a parameter, that's the value we would be setting to the property. For the function body, we could just copy the previous logic we wrote in our overridden set function. So we could copy this and paste this here, and instead of the field we'll call this number. Our building validator class is all set, and now it's time to use it. So now we can safely delete the get and set functions and replace it with the delegates. And so we would do number of rooms by building validator, and the number of stories by the building validator. Perfect. So this should work just fine. Going to our main function, we don't expect to have any errors. We're going to run this to be sure that everything is working as expected. And nice, everything works as expected. It prints out number must be non-negative when we try to set a negative value of 6 to the number of stories, and then it still prints out the previous values we had of 12 and 6. We could try to assign other values to the home. So let's give it number of rooms is 20 and number of stories would be, let's say, 5. We'll run this, and yes, it prints out, hello, my home has 20 rooms and is 5-storied. And so this is just a simple example of how you can delegate the implementation of your getter and setter methods to a delegate. Here we use the delegate called building validator. Up next, we are going to look at some best practices and tips on overriding property getters and setters in Kotlin. Here are some tips and best practices to guide you when adding custom logic to your property getters and setters. Firstly, keep it simple. When implementing custom getters and setters, you should strive to keep your code as simple and as readable as possible. This is because complex logic within these methods can easily make the code difficult to maintain. Also, strive to follow the naming conventions for getter and setter methods. Always prefix your custom getter methods with get and setter methods with set. This will help maintain consistency and clarity in your code. Use property delegations sparingly. While it is a great tool and can simplify your code, it is not always necessary. Use it when it genuinely reduces boilerplate code or enhances readability, but don't overcomplicate your code with unnecessary delegation. Document your getters and setters clearly, especially if your custom getters or setters perform non-obvious or very important operations. Document them thoroughly with comments so that other developers can understand their purpose and behavior. And also, don't forget to test your code. As with any code you write, test your custom getters and setters to ensure that they work as expected. You can try writing unit tests to validate their behavior, especially when dealing with a very complex logic. Also, maintain consistency. If you're working on a team project, ensure that everyone follows the same conventions for custom getters and setters, because this makes your code base more manageable and understandable. And finally, only override property getters and setters when necessary, because overriding getters and setters adds more complexity to your code, which would make it more difficult to maintain. Therefore, you should only override getters and setters when you have a specific need to do so. And that will be all for the tips and best practices. Thank you so much for following through this video to the end. See you next time. Bye.